So here we have a question. If the combustion analysis of 0.80 gram of an organic compound yields 1.63 grams of CO2 and 0.97 grams of H2O, then what will be the percentage of carbon, hydrogen, and oxygen present in that organic compound? So we are taking that organic compound as X, and then it is a combustion reaction, so we have to take O2, and then the product we are getting is CO2 and H2O. We know that the organic compound is 0.8. We don't know the oxygen, we have to find it, and then we know CO2 is 1.63 gram and H2O is 0.97 gram. The question requires the percentage of carbon, hydrogen, and oxygen. So first of all, for the finding the concentration of finding the percentage of CO2, we know that atomic mass of CO2 is 44 gram. So if for finding CO2 percent, we'll simply solve, like if 44 grams of CO2 has 12 gram of carbon in it, so 1.63 grams of CO2 will have X number of carbon in it. So we'll simply cross multiply. We'll multiply 44 times X is equal to 12 times 1.63. So doing the calculation, we'll get X as 0.44 grams. So this is our the concentration of carbon and carbon dioxide. So for finding percentage of carbon, we'll simply do the 0.4, which is carbon, and atomic and the whole CO2 is 1.63 gram, so we'll take it as denominator, and then we'll simply multiply it by 100. So we'll get 27.2%. this is the percentage of carbon. So we have found the percentage of carbon here. Then we have to find the percentage of hydrogen. Then we'll use this we will use simply this same steps we'll do for H2O. So we'll do same for H2O. Here H2O's atomic mass is 18 gram. So 18 gram of H2O yields 2 gram of hydrogen. Then 0.97 grams of H2O will produce will have X gram of hydrogen. So we'll do cross multiplication and we should get 0.107 gram of H. Then for finding percentage, we'll use same formula, which will be 0.107, which is the part of hydrogen, and the total amount we have is 0.97. So we'll just put it here and multiply it by 100. We'll be getting 11.030%. Then we have successfully find carbon and hydrogen percentage. To find oxygen, we'll simply just take such as 100% as a total. We'll minus the concentration, we'll minus the percentage of carbon, like minus 27.2%. then we'll also minus the percentage of hydrogen from it, which will be 11.03%. We'll get 61.77%. this will be our percentage of oxygen. So in this question we find all three, percentage of carbon, hydrogen, and oxygen.